In injection molding, both ejector pin accelerators and plate accelerators are used to provide a two-stage ejection sequence, but they differ in their mechanism and application. An ejector pin accelerator is a compact device that attaches to a single ejector pin and provides an extended stroke to release parts from undercuts or other features that might cause sticking. A plate accelerator, on the other hand, is a system that accelerates the entire ejector plate movement, often using a mechanical linkage to achieve a faster initial ejection stroke. Ejector pin accelerator. Mechanism: typically, a compact, robust unit that attaches to a single ejector pin. Function: accelerates the forward movement of a specific ejector pin to overcome sticking points like lifters, stripper plates, or deep core features. Application: used when a single or small group of ejector pins need to move further than the main ejector plate to release a part. Advantages: compact design allows for installation in tight spaces within the mold. Plate accelerator. Mechanism: involves a mechanical linkage or system that accelerates the entire ejector plate movement. Function: provides a faster initial stroke of the ejector plate to quickly push the part out of the mold. Application: used when a faster initial ejection stroke is needed for the entire mold or for specific sections of the mold. Advantages: can be more straightforward than complex hydraulic or pneumatic systems. The choice between an ejector pin accelerator and a plate accelerator depends on the specific needs of the mold and the part being produced. If the issue is localized sticking on certain ejector pins, an ejector pin accelerator is often the better choice. If a faster initial ejection is needed for the entire mold or a specific section, a plate accelerator may be more suitable. Key differences summarized. Ejector pin accelerator. Individual ejector pin. Direct attachment to pin. Overcome localized sticking. Generally simpler. Compact. Plate accelerator. Entire ejector plate. Mechanical linkage or system. Achieve faster initial ejection. Can be more complex. Can vary. Injection mold ejector plate accelerators, pros and cons. Pros: ejector plate accelerators. Improved part ejection: they enable the efficient and reliable ejection of parts with challenging geometries like deep core features or those requiring a two-step ejection process. Reduced cycle time: by performing a secondary ejection stroke without requiring a separate set of ejector plates, they can shorten the mold open time and thus, reduce the overall cycle time. Space saving: their compact design allows for installation in molds with limited space. Preventing part damage: the controlled, accelerated ejection reduces the risk of part deformation or damage during the release process. Cons: increased complexity: incorporating accelerators into the mold design and setup can add to the overall complexity of the ejection system. Potential for wear and tear: like other moving mold components, accelerators are subject to wear and tear over time and may require regular maintenance and potential replacements. Cost: the initial investment in ejector plate accelerators and their installation can be higher compared to simpler ejection systems. Ejector plate accelerators are valuable tools for mold makers and molders dealing with complex part geometries, but their advantages should be weighed against the potential for increased complexity and cost. Injection mold ejector pin accelerators, pros and cons. Pros: ejector pin accelerators. Improved ejection of difficult parts: accelerators actuate an ejector pin forward when additional pin travel is needed to release molded parts from elements like lifters, stripper plates, or deep core features. Space saving: they can create a second stage ejection without requiring a separate set of ejector plates, saving space within the mold. Ejector accelerator has a compact footprint, allowing it to fit between other mold features such as lifters, support pillars, and ejector pins. Shorter cycle times and increased production: these accelerators allow for shorter cycle times, increasing production efficiency. Simple solution for two-step ejection: they provide a simple, Space and cost-saving solution for injection molding processes that require two-step ejection to safely release a molded part. Flexibility and adaptability, they can be used for both new and existing molds. Cons: ejector pin accelerators. Potential for increased wear and tear. The added movement and force could potentially lead to increased wear on the ejector pins and associated components if not properly designed and maintained. Complexity and cost. While saving space compared to a full second ejector plate, they still introduce another mechanical component, potentially increasing complexity and initial cost compared to simpler ejection systems. Ejector pin marks. Improper use of ejector pins, even with accelerators, can leave marks or blemishes on the molded parts, affecting their aesthetic quality. Misalignment and lockup risk. If the ejector system is misaligned or if ejector pins do not float properly, gulling and lockup can occur, potentially leading to breakage or bending of the pin and requiring repair or replacement. Ejector pin accelerators offer a valuable solution for efficiently removing challenging parts from injection molds, enabling faster cycle times and increased production. However, careful consideration of their design, integration, and maintenance is essential to mitigate potential drawbacks like increased wear, cost, and the risk of ejector pin damage or marks on the molded parts. In injection molding, the choice between an ejector plate accelerator and an ejector pin accelerator depends on the specific needs of the molding process. Ejector plate accelerators are generally better for multi-stage ejection or when the part requires a longer ejection stroke, while ejector pin accelerators are more suitable for simple, space-saving solutions in limited space. Ejector plate accelerators. Function. Ejector plate accelerators utilize a second set of ejector plates to provide an additional stroke for part ejection, especially useful for parts with undercuts, lifters, or deep core features. Can handle complex ejection scenarios with multiple stages. Can be more space efficient than using multiple sets of ejector plates. Can be used for both new and retrofit applications. Can be more complex in design and require more space than single-stage systems. Ejector pin accelerators. Function. Ejector pin accelerators act on individual ejector pins, providing a short, controlled burst of force to help release the part. Simple and compact design. Cost-effective solution for secondary ejection. Can be easily installed in limited spaces. May not be suitable for complex ejection sequences or parts with significant undercuts. If you need a powerful, multi-stage ejection system for complex parts, an ejector plate accelerator is likely the better choice. If you need a simple, compact, and cost-effective solution for secondary ejection in limited space, an ejector pin accelerator is a good option. Ultimately, the best option depends on the specific needs of the molding process and the complexity of the part being molded. Choosing between an ejector plate accelerator and an ejector pin accelerator for maintenance and preventing breakage and wear in injection molds involves considering their primary function and impact. 1. Ejector pin accelerators. Purpose: primarily focus on providing extra travel for specific ejector pins to release stubborn or deep cored molded parts from undercuts, lifters, or stripper plates. Benefits for maintenance and wear prevention. Targeted assistance: they address issues with specific parts or features sticking in the mold by augmenting the stroke of individual pins, preventing forceful removal attempts that could damage pins or the part. Reduce stress on pins: by extending the stroke, they can reduce the stress placed on pins that might otherwise be strained when trying to push a difficult part out. Minimize pin mark defects: more effective ejection can help minimize cosmetic defects like ejector pin marks or part deformation caused by struggling to release the part. Improved reliability: can lead to smoother, more consistent part ejection, reducing the likelihood of unexpected pin breakage or damage during production. Potential weaknesses: if the underlying issue is with the overall ejector plate alignment or deflection, simply accelerating individual pins might not completely solve the problem or prevent other pins from experiencing wear and breakage. 2. Ejector plate accelerators. Purpose: focus on the synchronized movement of the entire ejector plate system, enabling two-stage ejection sequences without the need for a second set of ejector plates. They ensure the entire ejection assembly moves in a controlled manner. Benefits for maintenance and wear prevention. Enhanced overall ejection. By providing controlled, sequential ejection, they can aid in smooth and consistent removal of complex parts, reducing strain on the entire ejector system, including the pins and plates. Preventing ejector plate bending or twisting. Proper spacing of knockout bars or using additional bars to evenly distribute ejection force over the ejector plate, along with additional bolts connecting the ejector retainer plate to the ejector plate, can prevent the ejector plates from bending or twisting, and this is crucial for the overall lifespan of the mold. Promoting system stability. By controlling the movement of the entire ejection plate assembly, they contribute to the longevity of the mold components by minimizing abrupt movements and undue stresses. Potential weaknesses. While beneficial for complex ejection sequences, ejector plate accelerators might not address specific instances of pin sticking in localized mold features. Both ejector pin and plate accelerators contribute to better mold maintenance and wear prevention. The choice depends on the specific challenges presented by your molded part and ejection system. For localized issues where specific pins struggle to release the part, an ejector pin accelerator can be a highly effective solution. For complex parts with demanding ejection sequences and the need to ensure controlled, sequential ejection of the entire assembly, an ejector plate accelerator would be more appropriate. In many cases, a combination of these elements or a thorough analysis of the specific mold design and part geometry would be the most effective approach to determine the best solution for minimizing breakage and maximizing mold lifespan.